Good evening, everyone. Now, again, we came back with the interesting topic of Python, that is object oriented data pipeline, which help us in structuring the machine learning workflow. So, here we have different types of stages by which we are going to create the pipeline. We are here try to create a modular coding of the project that we are supposed to create. So the first step is data ingestion steps. Here it is the process of acquiring raw data from various data source. The data source might be the cloud database, or it might be some MySQL database. It can be anything from which we are going to extract the data. The data which we are going to extract is a raw data. After extracting the raw data, uh, we have to perform the data pre-processing steps. Here in data pre-processing steps, we are supposed to clean the data. It is a very crucial step in machine learning that involve transferring the data, raw data, that is the raw data, into a suitable format so that we can feed it to the machine learning models. After the data pre-processing, we have the data transformation technique. In data transformation, it is a process of modifying raw data into a more suitable format so that we can feed it to the model to analyze it better and get the meaningful insight out of the data. And the fourth stage is data pipeline. In data pipeline, it is a series of interconnected steps or stages that transform raw data into a format suitable for machine learning models. So these are the four steps that we are going to discuss in this video. So the first step is data ingestion stage. In data ingestion stage, before having all these stages, first we have to import the important libraries which are suitable to perform all these operations. So we have uh, first we are going to import Panda, which is used for data manipulation. Anyway, we are going to extract the data from the database, and after extracting the database, we have to manipulate it. So in that case, we are going to import pandas. So import pandas as PD. After that, we have to perform train test split operation because we are supposed to feed the data to the machine learning model. So we are supposed to feed only the trained data, not the test data. So for this, we are going to import train test split from sklearn. So we have from sklearn.model selection import train test split. Subsequently, for standardization of the data, as we all know that the data should be standardized before importing, before feeding it to the machine learning model. So for standardization and apart from standardization, we are not able to feed any machine learning model any categorical data. So we have to encode it. It can be one hot encoding, it can be label encoding. So here in this case, I'm going to use label encoding. So for this, we are going to import the standard scalar and label encoder from sklearn.preprocessing. We have standard scalar, comma, label encoder. Subsequently, we there might be any missing value in the data. So how we are supposed to deal the missing values? So we have one library which deal with the missing value also. So the library name is simple imputer. So to import the simple imputer, we are using sklearn from sklearn esteemed.impute import simple imputer. So these are the important libraries which are suitable for the all the process we are going to do. So the first stage, stage one, that is data ingestion. So for data ingestion, we are going to create one class for only data ingestion. So we have class data ingestion. So after creating class, we have to create one constructor. So in constructor, we are supposed to feed the data. So here we have data name called student performance factors. Here we are supposed to uh, check the performance of the students. So we are taking the student performance factor dataset, which is in CSV file. So after that, we have to write self.dataset. So to make it globally, student performance factor. Once we create the constructor, now we can create the different function to load the data. Here, the function to load the data, let's suppose we write the name as load underscore data. Here we have self print data ingestion loading datasets. Once we get into the load underscore data function, the pop-up will come which shows data ingestion, that is loading of the data, and we are supposed to return the self dot data set, the data set that we got. So this is the process for data ingestion. After data ingestion, we have data pre-processing. So to perform data pre-processing, this is the second step of performing data pre-processing. So to perform data pre-processing, again, we are supposed to create one class to perform data pre-processing. So this is class data pre-processing. In data pre-processing, also we have to create one constructor. This is the code to create constructor, that is self comma data. The data that we got, we are supposed to feed it into data pre-processing stage. First, we gathered the data from data ingestion stage, and then we have to feed this data to the data pre-processing stage mod so that we will pre-process the data, remove all the unclean data, remove all the miscellaneous things inside the data, so that we will able to feed it properly to the machine learning model. This is the code to have the data set. Once we have the data set, we have the different functions to perform different data cleaning process. So the first function is handling of missing values. Handle underscore missing values. This is self. So we are also going to print it that we are processing the handle missing value. Once we get into the function handling of missing value, we are supposed to split the data into two parts. The first part contained the numerical data and the second part contained the categorical data. So first part is numerical underscore impute equals simple imputer strategy equals mean. The second part is for the categorical data. So for categorical data, we have categorical impute equals simple imputer. Here we have strategy equals most frequent. So to handle the missing value for both the numerical data and categorical data, we feed the model that whenever we get the missing values in the numerical data, feed it to the mean. And whenever we get any missing value for the categorical data, feed it to the most frequent, that is the mode. So we, in first case for numerical data, we are performing mean imputation. And in second case, that is for categorical data, we are performing mode imputation. Once we do it, let's run one for loop to perform the imputation technique. If self dot data, where we have column dot d type, if the column data type is object, then we are supposed to perform categorical imputation. Self dot data column equals categorical imputer dot fit underscore transform self dot data columns. In the same way, if we are dealing with numerical data, so we have to impute the mean values using numerical imputer data column equals numerical imputer dot fit underscore transform self dot data column. In this way, we are supposed to fill the missing values from in the data. Once missing value is completed, we are supposed to perform the encoding technique for categorical data. So here in this case, we are using label encoding. So to perform label encoding, we have to write one function self print. First, we print that the pre-processing step, that is the encoding step, is in process. So first we have to import the label encoder, which we already imported. The library of label encoder is already been imported. After that, again, we have to run one for loop to deal with the encoding situation. data.column. If self.data column dot d type equals object, if the data type of the column given has object data type, so we have to encode it, equals label encoder dot fit underscore transform self dot data of column. Once we are done with all the pre-processing step, that is the imputation step and encoding step, we are done with the data pre-processing. Once we have done with the data pre-processing step, the third stage is to perform data transformation. So to perform data transformation, this is the third stage, stage 3, that is data transformation. Again, we have to create one class for data transformation. So let's create one class named as data transformation. In the data transformation, we have to create one constructor which take the data and try to transform it. So it takes the data and feed it to different function inside the class. So the first function is scaling of the features. So we have a scale underscore feature self. First we have to print it that the transformation scaling numerical features. Now we already import the data library for standard scaling. So only we have to assign it to one variable. So that is standard scalar. After that, whatever the numerical column which we have to transform, we have to perform this feature scaling to the numerical column only. So we have numerical column equals self dot data dot select underscore d type include equals, here we are supposed to include the int data type int 64 and float 64 dot columns. Again we have self dot data. Now we are performing the feature scaling for numerical data dot fit underscore transform self dot data numerical columns. Once we did this, we have to return the particular scaling dataset. Once we do this, we have to create the last stage, that is the data pipeline stage. So basically in data pipeline stage, we are supposed to have a series of interconnected steps or stage that transform raw data into a format suitable for machine learning model. So this is the last stage, that is the stage 4 of creation of data pipeline. So again, we are supposed to create one class for data pipeline. Here again, we are creating one constructor. In constructor, we are supposed to put the data set. After that, we have self dot data set that we got. So first function we are supposed to create is of execution of the pipeline. So we have def execution. Here we are supposed to write self. So this one is for execution. First we are ingesting the data using the data ingestion pipeline self.data set. After getting the data, that is the data, we are supposed to load the data. So this is the code to load the data. Once we have deal with the data ingestion stage, then now we have data pre-processing stage. In data pre-processing, first we have to create one variable equals data pre-processing, and we feed the data to that data pre-processing stage. And for handling the missing values, we have to call the function inside the class data pre-processing class. Again, for ordinal encoding, we have to feed the data to perform in ordinal encoding. So we are getting all the functions by using this code. And at last, we have data transformation. In data transformation, we have one class called named as data transformation. Within this, we are supposed to feed the data. Once we feed the data, whatever the transform result that we got, we again feed it to scale feature. And last, we have all the data pipeline executed, completed. So we are returning the data. Once it's done, now we write the main function to call the data ingestion pipeline to perform all the operation mentioned above. That is main data set is pd dot read underscore csv. We have student data csv file. Once we have the student data, we have to print that the data is successfully loaded. Once the data is successfully loaded, let's see the head of the data. After seeing the head of the data, we have initialize and execution, the data pipeline. So here we have pipeline equals data pipeline. Here we feed the data. Once we feed the data, all the pipeline processes got executed. Once all the process is executed, we have to view the data. So lastly, we print process data after pipeline execution. Then we have process underscore data dot head. So these are the process, these are the sequence in which we have to create any pipeline for machine learning operation. So that's it from my side. Thank you for joining. Thank you everyone.